Okay, let's do the correction now. Let's do the correction. Let's do the correction. So start by saying from equation 1. From equation 1, we have 2x plus 3y equals to what?
6,000.
Yes. So we say when x equals to
X
what?
is 0. Equals 0.
Allow him to teach.
So this is out. Y equals to 6,000 divided by
Over
3.
3.
So y equals to 2,000.
2,000.
Am I right?
Yes.
Then when y
Is 0.
equals to 0, it will be 2x plus 3, 0, Abi.
Yes.
Equals to 6,000. This is out. So 2, you can say x equals to 6,000
Over 2.
So x equals to what?
3,000.
Which means that y equals to what?
2,000.
And y equals to what?
2,000.
3,000. Who's that now?
So y is 2,000.
X is 3,000. Y is 2,000.
What happened?
X is
X
3,000.
is 3,000. Y is 2,000.
Let me put it on the platform, please. Sorry. What do you say? X is what? X is 3,000. X is
X
3,000.
is 3,000.
Y is 2,000.
Y is 2,000.
Okay, yes, that. Do I need to snap it? We all got it correctly now. I should not snap it, Abby. I share it. So we have gotten equation 1. Equation 2. X plus y, Abby.
Yes.
Equal to 4,000. So when x equals to 0, 4 x plus y equals to 4,000. Y equals to what? 4,000. Then when y equals to what? Equals to 0, that would be 4x
X
0 equals to what? 4,000. X equals to 4,000 divided by 4 equals to 1,000.
1,000.
So it will be x equals to 1,000. Y equals to
4,000.
4,000. Okay, now. That's what they asked me to do. You want it to snap it? No. Abby, thank you very much. Then equation 3. Equation 3 is y equals to 1,008. X equals to what? Equals to 0. Okay, now. Did I snap it? No. No. But it's not supposed to even take off without time we use. I'm angry this time around. I want to draw a good graph. Draw a good graph. It's really no good though. It's better now. Okay. What is the highest for Y?
4,000.
4,000.
4,000. Highest for
Yes.
3,000.
It's
3,000.
4,000.
Yes.
So what do you think we should use?
3,000.
Let's make it 5,000. That's what.
500.
4,000 is okay
This
since we are not exceeding 5,000.
Let's use
Yes,
5,000.
5,000.
500. Yes.
500, 1,000, 1,500,
1,500.
2,000, 2,500, 3,000, 3,500, 4,000. Abby? Yes. 4,000, 3,500, 3,000, 2,500, 2,000, 1,500, 1,500 is 0. It makes sense now. 500, 1,000, 1,500, 2,000, 2,500.
The spacing for X is too wide.
So we have 500, 1,000, 1,500, 2,000, 2,500, 3,000, 3,500. This is X what? As this? This is Y what? As this. Any problem? No problem. Let's start with note 1.
Yes, sir.
For equation 1, which is for label, Abby. When X is
Yes, sir.
X is 3,000. X is 3,000. Y is what? 2,000. Okay. The next one is what? Okay, so let's write the equation. 2x plus 3y equals to 6,000. Yeah, equation 2. When x is what?
When x is 1,000, y is 1,000.
When x is 1,000,
Yes, y is 4,000.
y is 4,000. When you are drawing graph, it's not something that will be shaking like this. So if you shake on your own, no, it has to be straight line. If you are using ruler, you cannot be doing it to make it more thick. No, just one line, thin line. Yes. Exam condition. Are you going to do what? There's measurement on your ruler now. Don't measure the field of bed. So the space you are living are harmony. So it's not bigger than the other. Sorry, I don't want to understand my question. Let me do explain to you. Please, I don't want practically. What is the relevance of linear programming is relevant as a practice.
Please, louder. We can't hear anything.
I don't know. Someone is asking. Someone is asking. What's relevant for this? I just want to get your way. Okay. Oh yeah, listen. The question is, what is the relevance of linear programming as an accountant? I mean, yes. The thing is that you must know that you have types of accountants. Yes. So the type of the accounting aspect you are looking at it is a financial accountant. A financial accountant doesn't need this one. But the cost accountant need this one. The other guy that is taking PM, Mr. Richard, is a cost accountant. And that's why I'm interested in bringing him to PM. Because that is what he's doing in his office. You understand? He's cost accountant. If you are into a manufacturing company, you will know the essence of this. Where you are stranded in the limited resources. Do you understand? You don't know how many units should I produce to maximize the profit. You have 1,000 materials on ground, and you have different requests from outsiders. You cannot just sit and say, because this one is my friend, I'm going to answer, I'm going to give him all the things. But other people, I cannot satisfy them. You will look at it. How many of these products should I produce? How many of these products should I produce? So that more money will come. Do you understand? It's actually for decision making. And then to maximize the profit, and then to minimize the cost. It's very important. If you work in the manufacturing company, it's very relevant. But if you have never worked in manufacturing accounting, manufacturing company, just read them and pass and get your certificates. I've worked in manufacturing. Okay. But they are not into the aspect to which I work. I not be really in the production. So that's why in the production aspect, because this place is production. So which of the equation is talking about this? 4x plus y equals to 4,000. We have one more equation, Abby.
Yeah, y equals to 1.
Y equals to 1/8. 1/8 should be somewhere here.
Yeah.
And x is equal to what?
0.
Where the focus of my screen?
Is it okay?
Yeah, it's okay.
I tried, Abby.
Yeah.
1,800, Abby.
Yeah.
Sorry.
Why?
Oh, yeah. Let us identify our physical region. Where's our physical region? Where is ABC and D?
In front of 2,000. No, in front of 2,000, that's me. That's yeah, that's
That's not it. A is that down part. That's where you go. A is from your dash to X. But you said even if it's a mathematics, you can start the inner part. And what is the inner? Is that from that? A from 2000. S for where? 2000. This one? Yeah.
1008. 8 from
1008 because of the line that crosses the.
You must pick another question after
It's
this.
1008 because of the line.
Look up again. If you want to minimize, take here.
So we can't hear you well.
Listen, you will hear me. If you want to minimize cost, you will shade from here, outside part, upward. If you want to maximize the contribution of profit, you will shade what? Inside. That is rule number 1 you must understand. Now, rule number 2, we want to look at where all these points are what? Where they are met. Abi? Now, I hope I've drawn the same thing perfectly with the same graph. Did I? Let's check it. So that I can use that one again to explain.
With the that they are towel. Now, things small. One water now.
No, please mute your mic.
The other time when I explained, I said it will have been here, here, here. Assuming there's no line here. Assuming there's no line here, it will have been 1, 2, 3. Okay, this one will not be able to do again. So that will be 1, 2, 3, and 4. Assuming the line is not there, it will have been 1, 2, 3, 4. Are we getting that now? And assuming this line is not there, it will have gone up a bit by saying from here, here, and here, and here. But because this line is there already, it has already demarcated, Abi, we cannot go beyond this line. We can only go below this line. Do we understand now? So it will have been this place. Feasibility region will have been this place. The first one we didn't write that feasibility region. Do you understand? But because this line is now there, yes, okay, it's coming here. So because this line is there, we can no longer go this way again. We can now move, we can now restrict ourselves between 1, 2, 3, and 4. Do we understand now? Because that is where we can see. This is where we can see. We cannot go out of
I thought you said this after this line. I thought it's supposed to be up.
Yeah?
I thought it's supposed to be after this straight line. Like now we are going down now. I thought it's supposed to be up for us to get our ABC.
That's supposed to be up now. This place is your feasibility region. Feasibility region. So which one is not supposed to be up again? This is your feasibility region. You cannot go out of this line because it must come in. It must come in. You cannot go beyond this line because there's a line that is demarcating you. And you cannot go beyond this because there's a line here. Do we understand that now? We'll still take another question, don't worry. So where are the points that we want to pick? Oh yeah. A, B, C, and D. Any question?
Yes, I have a question. So does it mean that all the region must just be limited between A and D?
No, it can be more than that. So it depends.
Okay, so okay.
Diagram you have. Yes, sir. We are following, how to get the point is the equation where those three equations intersect. All the equations we have used where they intersect. We have equation and this one. This is point 1. This is one equation. At this point, there's no equation that is intersecting here. So there's the equation that is intersecting here. There's the equation that is intersecting here. There's another equation that is intersecting here. This one. You can't use this one, but because it's out of this line.
I'm trying to say that very one.
That very
This C, yes.
This C, okay.
And we are y is 4,000 and then x is 1,000, which is C. So bringing C here.
We use D here.
That's the well,
And there's an equation that intersects here. You understand? There's no equation that is intersecting here. It's just ordinary axis. Y and X are meeting here. It's a normal intersection. But here, there is a line, there is an equation that is intersecting here. There's an equation intersecting here. There's an equation intersecting here. There's an equation intersecting here. We are only looking for the point where they meet, where they meet, where they meet. Do we understand? Any other question? Online, are we good? We are good. We are good in the hand of God. We have corner point. Corner point. Corner point. We have A, B, C, D. We have two products.
A.
We have two products. Product X and what? Y. What is our contribution? 5. Oh yeah, let's look at it now. We need extra I, Abby. We need extra I. So let's use our extra I now. When X, that is point A, Abby. This is point A we are talking about. Yes. Look up. When X equals to
0.
Y is equal to 1/8, Abby.
Yes.
X equals
Yes.
to what? 0. So X
0.
0. Y equals to 1,800. What is the total? 9,000.
9,000.
The contribution is 5. When X, this is the point. When X equals to
500.
200 or
300. 300.
300. Okay, whatever you say. When 300. Should we use 300? Thank you. So, when S is equal to 300, Y will be what? Y is 1/8. 1/8. What is the total?
10,500.
75.
10,500.
1,500. 10,500.
10,000.
1,500. Point C. Point C look like 1/5, Abby.
Yes.
Point 6 is 1/5.
600.
For my own book, it's 1/5.
1/5. 1/5.
So, point C, we can drag it down, Abby.
600.
600.
Oh, yeah, let's go. 5 is 800. Why? It is 1/5, Abby. What will be the total? What will be the total?
That's 11.5.
11/5. For the D, S equals to what? 1,000.
Yes.
And Y equals to 0. So S equals to 1,000.
Y equals to 0.
Y equals to 0. 5,000.
No. Y.
I'm sorry. I know it. I think it's 5,000. People of God. What is the optimum point? Point C.
11,500.
Point C is the optimal point. What does that mean? What are you going to write as your? Why are you casting your graph? You don't like graph? So what do we have as the? Well, how are you going to put it when you want to finalize?
The optimal point is that is minimize the contribution of the company.
Okay. So let's try. The optimal point is point C with contribution of 11,500. The optimal point is point C. But the optimal is point C, which we give contribution of what? Of 11,500. Therefore, the direction of the company is advised.
Please come again. We want.
Where exactly? The optimal point is point C. The optimal point is point C, which with 11,500 contribution. With 11,500 contribution. The organization is advised to produce 800 units of X. Am I right? To produce 800 units of X and 1,500 of what?
The company is advised to.
Of X.
Time
And
of Y.
1,500 units of what? Of Y. To maximize the what? To maximize the contribution. 1 minute. What is going on? We're not going till 9 o'clock today. It's marathon.
So we are fasting, no.
Oh, you are fasting. That will make it more faster. So grab it because you are praying. So the assimilation will very. Okay, that's the end of that question. The next question we are going to take now.
I have a question.
Okay, sir.
That we are picking the highest one.
We are picking the highest one.
Is there any scenario whereby we are going to have 2 points giving us
Yes, it's a good question. So in a scenario where you have 2 points giving you 11,500, 11,500, you will just advise the management. You understand? The optimal production are points A and C, as both give the same contribution. The management is advised to either produce 500 of product Y and 1,800 of product Y, or do you understand? The second one that is giving you maximum, you put it there and you leave it open for them to pick. Is that clear? Have I snapped this? No. Let's pick a question that will minimize the cost. Next week, by God's grace, we'll now pick a question where we're going to treat dual price and then the other shadow price and dual price the same thing. Then we will now look at tabular method. After that, we are done. Simplest method or tabular method. I have never tested that method before, but it might be from your own tongue. So we'll make sure we touch it. Let me look for the question that have the what do you call it? That have the minimization stuff. I don't have it here. Maybe we should pick a question that will treat the dual process. Let me check what I have there. Okay. Let's leave this one. Let's take a question. I don't have a question that will take. Are you with your Omala textbook here? No, okay. Don't worry. Let's take a question that will handle shadow price. Now, you understand? So next week, you know that we are going to minimization of the cost and then the simplest method. Are we good to go? So let's cancel this one. It's there. If you are there, I am there. Question waiting. Question 3. Is it question 3? What we just finished solving now is question. What we just finished now is question.
Practice question 1.
Last question. Practice question 3. Does it have that shadow price? It's not having it.
Sorry. But let's hear. Sorry, John. Don't mind.
It does. Let's go. Let me see that question. Okay. Question 1. Okay. Mark 1, Mark 2,
Go mute your mic.
Okay. See, go to, let me quickly explain that dual price. After the dual prices, then we now say we take a question on that. Do you understand? So let's read. When you said dual prices, they said every constraint has a dual price. Also known as what? As shadow price. Are we following? The dual price of a constraint is the change in this objective function. Page 13 is the change in objective function that is brought about if a constraint is changed by what? By a unit. What we are saying is that if we say this is a constraint, the constraint is 6,000. The constraint is 4,000. If it is changed by just 1 unit, by extra unit, if we add extra unit to it, what would be the effect? You understand now? That's the meaning of shadow price. That is the meaning of what? Of the shadow price. So let's continue. The dual price of non-limiting constraint is what? Is 0. When there is no limiting constraint, that is 0. But in a situation, this should be obvious. If a constraint is non-limiting, a small increase or decrease in its availability will have no impact on the value of what? Of objective function. Dual prices of limiting resources. Dual prices of limiting resources always have a what? Always have a value. This may be positive or negative depending on whether it is calculated by reducing or increasing availability of a resource, and whether a problem is to maximize or to minimize the cost. How do we calculate the dual price or shadow price? When the solution is found to a linear program, it is very easy to calculate the what? The dual price. The thing is that the first thing you must be able to do is to put it in form of equation. Equation 1, equation 2. But that limiting constraint, like the question we just finished solving now, labor is equal to what? 6,000. 6,000 is the limiting hour. Do you understand? The second one is what? Material, which was 4,000. The next one is sales demand, which was 1,800. Those are the constraints we are talking about. So if it is increased by 1, what will be the effect? Dual prices are calculated one at a time by taking the following step. You will calculate the equation 1 on the dual price. You will take equation 2 on the dual price. Do you understand? Increase the limit of the first limiting constraint by what? By 1. You are only adding it by 1. Then recalculate the values for the what? For the variable. Then recalculate the value of the objective function and compare with the new figure to the value of the objective function in the original solution. People of God, the difference is what we call the shadow price. We are going to demonstrate it now for you to understand what we are trying to say. But when you are calculating, make sure you also understand what you are calculating. Because I remember when I was writing my PM, question 1, it was linear programming and the mixture of limiting factors. So they asked me, what is shadow price? They asked, what is the limitation to linear programming? I'm still going to drop that one as well. I think it's not in that note. So they asked me limitation to linear programming. And then another theory. So I did the calculation and I also did the objective. You understand? So you must make sure you know. And also, examiner can test you the other way around, the way they tested Eva water last diet. Eva, they calculated everything. They now ask you to be explaining how, why do we do it this way? Why do we do it this way? So you must understand why we are doing, not to cram, but understand it very well. This is why we are doing this. Do you understand? Okay. Then this process is then repeated for the other constraints. So it means we are going to do it one by one. Labor, you will calculate the shadow price for labor by adding 1 to the constraint. When you are done with that, you will go to the material. You will add 1 to it. You will calculate, follow the same process. And that's it. Okay. Where are we? This is illustrated below using information from an earlier example, which is repeated here for your convenience. This is a continuation of the question from what? From previous chapter. So here now we have labor, and the labor is what? Okay, let's leave this one. We have Mark 1 and Mark 2. And we have the contribution to be what? 10 naira per unit for Mark 1 and 15 naira per unit for what? For Mark 2. Are we getting that? Then we have direct labor. They say resource available. It means there's a limitation. Material is 24,000 kg. Direct labor is 18,000 hours. The optimal solution was found to be whatever. So what I'm going to do is that we are going to do this one from beginning to the end. We have not solved this question before now. It's not part of the question we have solved. So we are starting from the beginning. But we didn't solve it yet. So that's what we want to say. Because it's talking about dual price. Oh yeah, let's start. What is the first step? Stop here. Are you ready? Define
variable.
Because here they are yet to define the variable. What they are only telling us is Mark 1 and Mark 2. What is not Mark Angel? So we have to define the variable. So let's X represent Mark 1. Let's Y represent Mark 2. We have defined the variable. Any issue? What is the second thing we have to do?
Objective function.
Objective function. Contribution equals to what? 10 naira. It's no longer mark. It's now what? 10x plus 1. What is second contribution?
15Y.
15Y.
Equals to 10. Or you remove the 0. They cannot confuse. Contribution equals to 10x plus 5y. What is the next thing to do?
Identify constraint.
Constraint.
I constraint. See, if you want to write here, don't rush to the solution. Try to do some analysis for them. Let them know that you understand this. You understand? If you like, you can call this one. Identify the constraint. So here now, direct material.
Direct labor.
The constraint is what? No, the constraint is what? 24
EX.
24,000
kg. Abi?
Yes.
Direct
Direct
labor,
labor.
18,000
18,000 hours.
20,000. What's the next one?
Sales demand.
Sales demand. 5,000. Abi? I want to call it.
We don't.
Yes. It varies. It varies per product.
We are saying 5,000. We are saying unlimited.
Sales demand unlimited. Okay. No wala. Let's leave this one for now. For sales demand, there's only one part that has the constraint. When you say unlimited, it means there's no constraint on that. But for the one that have limited, there's a constraint. You understand? What's the next one?
Formulation.
Formulation. Formulation for first one.
Criteria.
Two,
We are looking at the
two
table.
X.
2x.
4X.
Or four.
Okay.
Four.
Equal to 20.
Oh, what are we doing? I think this.
Less than 24,000 kg.
4,000. Are we sure? Why? Available, they cannot go beyond it. That's for material. For labor, what do we have for labor?
3X plus 2Y is less than 18,000 hours.
Any other thing?
Non-negativity.
Why now?
Sales demand.
Are you sure we are done with it?
Sales demand.
And we should leave sales demand. You told us to leave sales demand. That since it's not having any constraint.
Okay.
So what do we have for the two? In the question, it says demand is not limited, Abby. Maximum sales demand is 5,000. Maximum. But for the other product is what? It's
Unlimited.
So how do we calculate it? Can we do the calculation for this? Equation 1 and equation 2. Eh?
Yes. Yes.
Since wait, just listen. Since the Mark 1 is having maximum of what? But the other one doesn't have anything. You only draw a line for only sales demand. And that will be for X. So it means when Y equals to 0, you understand? X is 5,000. Then you draw the straight line. That counts to it. Do you understand? Oh yeah, let's calculate this one. Finish it up. Equation 1, equation 2. You should be able to solve it now. What's the time? Maybe we are going to 7 now. You can solve it within 30 minutes. Try it. Draw the graph. Get the maximization. Write your comment perfectly before we now move to the dual price. Whatever you get, that's what I'm going to accept. You understand this thing? Am I right? Yes, Abby?
I'm not done though.
Come and what's that the guy? I mean,
Which guy?
yeah, come and go. Identify your. I'm that. You know there are three equations. Don't forget those. Tell you know there are three equations. You know there are three equations. You know there are three equations. What is that one? Online, are we doing it at all?
Yes.
Yes.
Because physical people, they are trying here. They are making me proud, small. I'm seeing a good graph, a good graph there. I will have asked you to drop it on the platform, but people will spy and they will copy it. So you don't need to send it to the platform. I should just try it and bring this topic again. We will show them pepper, right? Or you prefer it more than limiting factor? You prefer limiting factor to this? You prefer this to limiting factor? This one look more simple.
As in simpler than limiting factor.
Okay, simpler than because at the point of ranking, I'm knowing that limiting factor now. But they can also see it as I'm going to pick a question. We are going to pick a question last week. I mean next week. You have been looking at. But as long as you can see that two constraints are there, okay, I will check. I will give it as an assignment. I will not use it as a correction. Oh yeah, everybody, let's go. Anywhere you did, you don't try. You pass. You pass already. So we have to find the value of x and y in equation 1, 2, 3, right? So we will say, let's pick equation 1 first. Equation 1. 2x plus 4y equals to 24,000, I mean?
Yes, sir.
One class, please. So we say when x equals to what?
Our x equals to
0. So it will be 2.
plus
This one is out. One class, please. So we say y equals to 24. So y equals to what?
6,000.
6,000. Then we come to the second one. When y equals to what? Equals to 0. It will be 2x plus 4, 24,000. How? Okay. Question 2. Three x plus 2y equals to 1,000. 118,000. So when x equals to what? 3, 0 plus 2y equals to 18,000. I mean, so y equals to 18,000 divided by 2. So y equals to 9,000. I mean, when y equals to what? 0. 3x plus 2, 0. I mean, equals to 18,000. 3x plus so x equals to what? Equals to y equals to chicken now. Then from there we draw our graph. If you're unable to get this one, I will find you. Big fine. Oh. The next one is to what? Is to draw the graph.
Plot our graph.
Yes, to plot the graph. What's the highest value of y?
9,000.
Highest value of x?
12,000.
10,000.
Let's make it 3,000.
Yes.
Or 1,000. Okay,
1,000.
Let's make it
1,000.
1,000. 3,000.
1,000.
With 1,000. 12,000.
2,000.
Yeah, 2,000 is considerable.
Anyone is okay. It just depends on your rating.
I think this one will make more sense, I mean. One has IS.
S is the one that have IS.
When X is what? 12,000. When X is 12,000, Y is 6,000.
The equation is 2x plus
2x.
24,000.
Question 2.
When X is 6,000, so when X is 6,000,
When X is 6,000,
Y is 9,000.
Y is 9,000.
Yes.
Ah, confirm. I tried, Abi.
That's 3x plus 2y.
3 plus equals what?
18,000.
Yeah?
Then we have x plus 5,000.
And Y is 0, Abi.
Yes.
Make a manage us like that. Okay. What is it? Well, it's straightforward now. I look up and get it this time around. This is top graph we are drawing. I mean, you must get it now. You will now look at it where all these things are met. Met here, met here, met here, and met here. You also met here, but because this line is already, so we will not go beyond this phase, we will stay within here. They also met here, but because this line and this line has cut it off, we cannot go beyond that. So our physical region now is visible region. We have A, we have B, we have C, we have D. A, B, C. This is C here. Any question on that? It's perfectly clear. Online, are we together?
Yes.
Yeah.
Okay.
Yes, sir.
Okay, so let's complete it before we snap. We have point. Okay, we didn't write this one. This one is
X is possible by so A, yeah, then
corner points. It's not that everything must be D, O. Sometimes it's not more than A to C. Sometimes it's A to B. What is the contribution? 10, I mean.
X is 0.
X and Y.
Then so that
10 into bracket
0.
under point A. When Y is 6,000, X is what? X is 0. X is 0 plus 15, 6,000. What is the total?
90,000.
90,000. How many people got 90,000?
I.
I did.
You got 90,000.
Yes.
You don't correct it. No. Okay. I will have give you this laptop to go with it. Okay, then
X
for B, we have Y. Okay, let's talk about X first.
Y is 5,000. X is 5,000. Then all the 5,000. 5,000.
This cannot be 5,000.
Y is 43.
5,000.
3,000.
Okay, let's
Y
pick
is 43.
let's pick 5. So 5,000 for Y now. Abi?
Y is 5,000.
5.
It's not.
It's
Yeah.
not 5,000. We that we use 1,000 unit. It's not up to.
Okay, don't worry.
It's difficult not be angry, it's not the same.
I don't worry. You cannot use the same thing, but don't worry. Whatever you have done is correct. I'm going to accept that. So let's say X is 35, Abi.
Yes.
Let's say X is
3,000.
S 35.
3,000.
3,000. I suspect 3,000.
35.
X is 3,000.
35.
Okay, 35.
Y is 43.
X is 5. What is the total?
4,500.
Yeah, you see, what is the total? Oh yeah, what's the total? What time?
110.
110. 110.
110,000. 110,000. Yes, now.
Okay, 110. Then C. She look like 2,000, Abi.
See,
S is
like 5,000.
S is 5,000. Oh.
5,000.
X is
Y
5.
is
One. Sorry, Jare. S is 15.
And Y is like
Y is 15.
It's
15.
like 1.8.
Sorry. S is 5,000.
So,
Y.
now we have done X.
Y is 18.
1.8.
1,500.
So Y is like 1,008. What is the total?
18.
Yes, what is the total?
77,000.
47.
77. 7 and 7.
Okay. Are we good to go? The next one is D. Point D.
S is 5,000.
X is 5,000.
Y is 0.
Y is 0. What do we get? 50,000.
50,000.
Optima is what?
B.
Optima is B. Optimal point is B. What does it mean? What does it mean? It means the organization should produce 3,500 of what? Of eggs. And 5,000
units.
to maximize the contribution. Any other question? Why is he sleeping? How are you going to school? Do you need you want us to start with food?
So what's not
Not serving. Sorry. This banana is not fasting. Are you sure you are fasting? Are you sure? I want to audit you before, but don't worry.
the ultimate point?
Oh, yeah, right. So the ultimate point is point B. We have not even done the part supposed to do.
Which means because
The shadow price. Oh, yeah, very quickly. Let's do the shadow price. Therefore, yes, they should produce whatever.
Yeah. The company is advanced.
Now, let's now go to the new thing we want to learn. Shadow what? Let's call it dual price. Did I call it dual price or you call it what? Or you call it shadow price? It's the same thing. So the dual price, we know already that our maximum, our optimal contribution is 110. Have it? We don't want to do. What if it's increased by a unit? We now say, okay, what is equation 1?
Question 1 is 2x plus 4y equals
2x plus equals to what?
24.
24.
We don't need that for now.
Equation 2 is 3x plus 2y equals 3,000. Equation 3 is x.
So you don't need equation 3. You understand? Equation 3 doesn't, we know the x already. So the problem is between this and this. If the constraint that we said they cannot go beyond 24,000, if we increase it by 1, that we say, okay, sorry, because of the limited we have, you cannot go beyond 24,000 hours. Now we are giving you 1 extra hour to produce. What will be the effects on the contribution? Are we let's start this now? We say, sorry, that 18,000 kg, we say you can use. What if you use just 1 kg to it? What will be the effects on the contribution? That is shadow. So we'll now come back and say, okay, we want to talk with equation 1 first. We'll do the equation 1 first. When we are done, we'll do equation 2 again the same way. So we say 2x plus 4y equals to, instead of 24,000 now, you will add 1 to it. It becomes take we are no longer using this one again. We are now using this second equation. Huh? What is it? We only add to this first one. We will calculate the contribution again. We will now find the difference between the optimal we have gotten and the new contribution we are going to get now. That is the shadow price. Once we are done with that first one, we will add one to this again. We will not add one to this again. We will do it the same way. Whatever we get as a contribution, we will less it from the optimal. The difference again is the shadow price. Do we understand that?
So let's add one.
We have two types of methods, but I'm taking you only this method so that you not be confused. So let's go now. At this point now, at this point now, I will take you back to your secondary school. I want to take you back to secondary school. You can use substitution method or you can use elimination method. Me, I like
Elimination method.
I prefer elimination method. So I want to eliminate what? Let's eliminate what? X. The rule is that when you are eliminating, because we are eliminating X, the coefficient of X must be the same thing before you can eliminate. So it means this one might be 6. If it is 6, this one also must be what? 6. This one must be 2, and this one must be what? Must be 2. Here we are getting the Another rule is that the two must be the same thing. One must be positive, the other one must be what? Must be negative. So my aim is that these two figures should look what? Alike. And the only thing I can do to make it look alike is multiply 3 by this and multiply 2 by this. By that, they will look alike. So I will say, okay, multiply everything here by what? By 3. And multiply everything here by what? By 2. So I will now move on and say 3 times this 6x. 3 times this give you what? Yes or no? Yes. 3 times this give me what? I will multiply this by 2, I mean 6x. Plus 4y. We now look alike. But there's one more rule I must obey. What was the positive?
Adding negative.
Negative. So to make any of this one negative, make the other one positive. So I want to make this one negative, I mean. It means I will multiply everything by negative. Minus times plus.
So,
Minus.
Minus times plus.
Minus.
Minus times plus.
Minus.
Any question? No question.
Please, can you explain that please again?
Normally, what do you say? What do you say?
I want to understand what you're using to multiply.
This one, it should not be, it should be positive. Okay, so is there any issue with it? I said the rule is that one must be positive, one must be negative. And to make the other one negative, it means you multiply everything by negative. You understand? By the time you multiply everything by negative, Assuming this one is negative before now, and you multiply it by negative, it returns to what? It returns to plus.
Plus.
Do we understand that now?
Yes.
Until something like this, that's where you can now eliminate. That is 6x minus plus 6x. That will give us 0. Do we now understand now? But if it is positive x and positive x, it will give us 12x.
12s.
So we have positive 12y
Plus 8y.
4y. What do we get?
Plus 8y.
Plus 8y. 7203 minus 36. 86.
30.
Do we understand?
Yes.
So equals to 36 or 3 divided by 6. Y equals to what? 1000. Abi, am I right? So that is value of 1. We will now go to the second one and say substitute for what?
For y.
For y. Anywhere you see y, you replace it with what? In equation, you can pick
1.
any equation from the original equation. For me, I will pick equation 2. From equation 2. Are we getting that now? I will say 3x plus anywhere I see y, it becomes what? 4,500.4. What is the total? 18,000. Yes or no? So 3y, 3x plus 2 times this, what is it? 9,000.8 equals to 18,000. 3x equals to 18,000
minus 9,000.8.
negative, minus 9,000.8. So 3x equals to what? 899, Abby. 8999.2, Abby. So x equals to 8999.2 divided by what? 3. So x equals to what? 2999.7. Yes or no? So we know the value of x, value of y. We will now go back to original contribution. The contribution equals to 10x plus 15y. We will say 10. What is our head? 2999. Plus 15 times what? 4,500.1. 0.4. So contribution is what? Total contribution is what? We have to go. What is the total Sure. What are the times? Almost 7. 97,503. You understand? You will not do the 97 what? Am I all right? You will now compare it with the optima. Our optima is what? Remember our optima. What will be the difference between the two? What is the difference between the two?
12,000
9,000.
497.
12,490.
497.
Any issue? No. For other material, so yeah, material. Other labor, you will not look for material. Let me just put you through before you go, so that I can give you a very big assignment. I can have opportunity to give assignment. If you like, go to our, and you know. Okay. It's on the platform, it's on the platform. Don't worry. Me, I not go finish am o. I will just put you through, you go and do it yourself. So the equation remains the same thing. We have done for the first one. We will now repeat almost the same thing. We will say 2x plus 4y equals to 34,000. Equation what? Equation 1. We will say 3x plus 2y equals to 18,001. Do we understand that? Then what's the next thing to do from here? Eliminate x now, or y now, or x. Whichever way. Eliminate x. So to eliminate x, or let's eliminate y. Yeah? It means we multiply this by 1. By 1. By 2, by 4, by 4. Not way, not by. Yes, every time you can multiply down by 1 now. Huh? No, guys, what's the big y? Not here, we can multiply that to y, and now we'll see it 4. Now so line 4y. You now leave the other equation like that. You not just don't worry. Let's do it this way. Two times 2x. What do you get?
Double digit. One camera.
48,000.
48,000.
One.
This one.
Thank you. Thank you. Thank you.
72,000.
Saturday, on a Sunday.
You
Online.
understand?
Madam Chidinma, please, please, and please. Thank you.
We have done we have followed the procedure that this thing must look alike, Abby, but the sign is here to look alike. Yes or no? We will multiply negative by whichever we want. Which one should we multiply negative? So let's say this one is negative, Abby. This one, then this one will turn to what? Because negative times plus, negative. Negative times plus, negative. Negative times plus, negative. Do we get that now? This one will cut each other. It's out. Yes or no? So the difference between this is what? 8x. Positive 8x. Yes or no? Yes. What's the difference between this one? 72 minus 48. 24. 4. X equals to 24,004. 3,000. 1,5. Then substitute for what? Substitute for y. I mean for x. I mean. So anywhere I see x, it returns to what? So you can pick any of the equation. Let's pick equation 1. So anywhere we see x, it becomes 2 point what? Plus 4y happy equals to 24,000. This times this 6,000 happy. 6,000 minus 6,000 what? 1. 6,001 like this. Plus 4y equals to 24,000. Am I right? So it means 4y equals to 24,000 minus 6,001. Am I right? Yes. So y equals to 70,000. So that is 4y. So y equals to 17,999 divided by 4. So y equals to what? Am I right? So from there now, we cannot look at the first contribution. Okay, let's do the contribution. C equals to 10x plus 15y. Are we right? So it means it's going to be 10. What is our head? Plus 15. 4499.8. Are we getting the gist? Oh yeah, let's multiply. What do we get? 30,005. $47,497. Total. 97.
That's 7502.
67. 497.
Yes.
497.
97,525.
Okay, the total will still be
My love.
97,502.
502. You now compare with the optimal. 110. The optimal. What will be the difference?
12,000.
498.
10,000.
498.
10,498. Is that what we got in the beginning? In the first one?
We got 12,497.
Because you are considered that.
So the shadow price is this and the first one. How are you going to know that what you have done is correct? The first answer and the second answer must be close. If it's not close, okay. Any other question, ladies and gentlemen? So this is the shadow price for material, and that's the shadow price for the product. My online people, any question?
No, sir.
All right, make sure you do the assignment and go to drop. Please, practice make perfect. Next week, by God's grace, we go to minimization of the cost and in the simplest method. Do you understand? Thank you very much.
Thank you very much, sir. God bless you.
Thank you, sir.
But I can have not tested it before. Oh, that's very simple. You will pay us extra money. Yeah, that's what you say.
Can stop recording.
No, it's not possible. It's 1-1. 4 now. We used to do well for FA Cup. It's only league that I'm not that sure. It's only the league I'm not sure about.
Stop recording.